So let's start with company updates.
So first off, I'm in Asia right now, and it is 1 in the morning. So I don't know if we move the meeting next week,
Okay.
but we should really find a time that works for everybody. Um, I just posted that market cap thing, I know it just feels like everything takes so long. It feels like all Tinygrad takes so long, and there's so many pieces, and like, oh, well, why are you writing a DSL for assembly language? Um, just always remember that the biggest two companies in the world are both the only two companies that are successful at building chips to train AI. Right? The biggest company in the world is NVIDIA, and the second biggest company in the world is Google, and they're the only companies with AI training chips. And it's just kind of interesting to notice that. Um, so then, like when you think about TinyGrad in perspective, like, does anyone have a better way to do this? Is there anybody out there who has a better? This is just really hard. But yeah, no, I think we can succeed at it, and it's just gonna take a really long time. But if you don't think that competing with, I mean, at the end of this really long time, you end up competing with the actual two largest companies in the world. So something to something to think about.
You don't like Cranium?
I mean, it's also interesting that almost every other one of those companies on that list has tried to build a training accelerator. Except for Saudi Aramco
And TSMC.
and TSM. Well, TSMC builds like TSMC makes it's crazy. I mean, just look at those are the biggest companies in the world. But we'll get there. But it's going to take a really long time. And I'll reassert the tiny grid thing over and over, which is that all of these things, instruction scheduling, kernel scheduling, register allocation, memory allocation, they're all the exact same problem, just at different scales. And the first step to unifying them is to bring them into a unified framework. Right? There's no way that if register allocation is being done in LLVM, there's no way that that's going to use the same logic as the Torch memory allocator, which is done in Torch, but you have to use the same logic. Right? You just want to build one really good one. You don't want to keep rebuilding stuff over again. It's also notable that uh, neither NVIDIA nor Google uses LLVM. Whether LLVM is capable of uh, training big models is an open question.
Uh, I know I reversed the order, but since it's late for you, George, you want to finish your assembly stuff first?
Oh, no, I'll stay up. I'm here. Let's go with that order.
Sure. Then let's start with Chris.
Yeah. Yeah, so I started working on getting the performance counters to work for Qualcomm. I think that'll really help out trying to understand what is keeping image equals 1 slow. So that's a good thing to work on. And then the other thing, unless there's stuff to talk about with respect to that, is C-types, which is coming along. There's a couple things I still need to iron out, but that should be done today. The new C-type stuff. It's the IntelliSense stuff is better. I checked it out. It's not perfect, but it is better than what it was previously, which is that it didn't work at all, and now it works sort of. I don't know. I don't exactly know how PyLance works, so I'll have to take a look at this and try and figure out exactly what's going on here. That's causing it to not show the actual types properly, but sometimes the functions don't properly show the types. And I'm not totally sure why that is, but I will. It should definitely be doable. I just don't. I don't really. I'm not familiar with Pylance enough to know why this is not working yet.
So, I mean, there's Pylance and then there's MyPy. MyPy is where I'd really like it to work. I never found Pylance to be that. I mean, I guess it is nice to have it like light up in the editor, if that's what you mean by Pylance.
Yeah, that's what I mean. Is like when you mouse over in VS Code, like you mouse over a function, it should show you the types of the
Yeah.
arguments of the function and what it returns. And for some reason, it's not doing that. But MyPy seems to understand it properly. I got to double check that this is the case, but MyPy seems to understand what I'm writing down.
Yeah, we should probably have some tests that like assert, like designed MyPy failing tests.
Yeah. I'll look into that. That's a see how easy that is to write in PyTest. But it should be good.
Yeah, I
In
don't know.
CI, we also generate a report for MyPy. I think they have some stats for how many lines are inferred as any and how many of those are properly typed. Maybe start with that.
Yeah, that could be good too. But yeah.
Oh, that's cool. Yeah, we don't need to falsify it. We can just see if the types are actually validating correctly.
Well, yeah, that's the generate report thing. Or what is something like that? Report something.
I'm not sure. But yeah, no, I just look at the MyPy options.
Yeah.
And what I'll say about the performance counters is, I mean, we know one of the major reasons for a regression, right? Like we have to support 2D images.
Yeah. Oh, for sure.
So, I mean, I think performance counters are a good idea, but I think it's probably more important to get the known stuff first. And
Okay.
then, once we're in the unknown, well, in the unknown, but
Okay. And the advice on how to do the 2D images is just like a super late rewrite to like transform the image.
yeah, so you'll have to do this at the same place where we do like the valid masking stuff now.
Yeah.
Um, but yeah, I mean, that should be fine because it's float 4 by then.
Yep.
Yeah, just make the index 2D, and yeah, do the rewrite there.
Yeah. Okay. That makes sense.
Yeah, and then extract what the 2D things are at the end when you need to pass them into the texture, the sampling code.
Yeah. I mean, there's only like if you have multiple things where you're relying on this valid thing, you can only do it. You can only like perform that operation once, so you have to track that information. But
Yeah, I wouldn't. Well, so is that even true? Can't you just put it in twice and give it two different sizes?
yeah, but then you'd have to pass it to the. Yeah, you could do this. You could do this. You'd have to pass it to the thing twice. You'd have to pass it. You'd have to like make it a two function. Like the function has to accept multiple parameters.
Yeah, I mean,
Um,
what you might want to do is you might want to, when you do the rewrite of the load, you might want to rewrite the define global as well to have the sizes.
I yeah.
I mean, you can keep the image D type. Just the idea is that you don't use it anywhere in the front.
Yeah, for sure.
Yeah.
Yeah, okay. I mean, so that's an interesting idea to pass multiple copies of the like every time you want like a special valid thing, then you pass another copy of the buffer.
Yeah, I mean, you can see if it ever happens.
Yeah.
But yeah, I mean, if you were to like put that type on the define global, then it would dedupe, then it wouldn't dedupe the define globals. Then you can pass another copy of the buffer with a different symbol.
Uh, okay. Yeah. Is that okay to do that late? With that, there's no operations that have to happen on the define global before that step.
No, I mean, you could rewrite the define global with the image type, right?
Yeah. Yeah. No, I
And
know, but
then,
I'm just worried about doing it so late in the. But I guess it's probably fine.
oh, it's fine. But yeah, no, if you then were to, I understand. So basically, what we're talking about here is you have two different loads that access it in two different ways, and we don't have a global like uniquing mechanism for that.
Yeah.
Yeah, I mean, I would just see if you can just have it just rewrite it anyway, and then just pass it in twice.
Yeah. Okay, that makes sense. Yeah. Yeah, I mean, probably like the quote unquote proper way to do this is to have two different samplers. it doesn't, like, at the end of the day, when it goes into the ops QCOM, it's like the same thing, so it doesn't really matter.
Yeah, I mean, you can decide they'll still have the same arg number on the defined global. They'll still both be like 0. So maybe you can actually make it have a different sampler, but just different sampler.
Okay. Okay, that's
Right, don't
cool.
change. Yeah, oh yeah, don't change the arg number on the defined global. The thing that'll make the defined global not dedupe is if they have different types. Right, you'll get all this kind of for free.
Yeah, no, the thing I was thinking was that you would pass, like, because you're just installing all these in the constants, like, as constants, like, that's where the arguments go. So I was just like, oh, well, you just, like, install another copy of it.
Yeah,
But yeah.
it doesn't matter. Doesn't matter how you do it.
Okay.
Anything else?
I think that's it. Yeah.
Let's move on to drivers.
So the noise timer copy for AMD is merged. So in VDA decoder speed is now fully JITted and it's 1580 frames a second with beam equals 1. So yeah. Yeah, also applied some like macro optimizations for MI350, MI300. So it's a bit faster HDMI now. So actually, all to all, on MI350 is 150 gigabyte a second. So, like the target is 220. But still, we have like compute kernels in front of this because of contiguouses. So, yeah, that's apart from that, that looks good.
The target is 220 or 179.
MI350 is faster, so 220 for MI350.
Okay, and we're getting 150 now. What's the gap?
Yeah, I mean, we do have like compute kernels in front of this because of contiguous, and we just copy like the data.
But that should be so fast.
It's not really fast.
Wait, but shouldn't it be? You're saying it's making a copy, but that should be like 8 terabytes a second or something.
Yeah, but no, actually, yeah, we do 2 copies, and I know, but actually, it takes up about like 80 US, 800 US, and like the whole copy is like 6 milliseconds, so it's about 1/7 of the whole time.
Yeah, it doesn't make sense to me because it should be like, how many gigabytes per second is that contiguous happening at?
I don't have exact numbers right now, but I think yeah, around. I mean, several terabytes definitely. I'll check that.
I'm surprised that it's even noticed, like barely. I'm surprised that it's like impacting things almost at all. Copies are so fast. Also, why do we need the copy?
So we actually do copies now because of contiguous, but potentially we do not need these copies. I mean, we can be smart and apply some views.
Cool.
Yeah.
About any look into Mac USB?
No, gonna do this week.
Yeah, seems like you're mostly on track with your sprint. Oh, I looked into idle a bit. Idle power. I think that there's no the SMU just doesn't support it.
Yeah. Actually, they just keep adding like new features in the new firmware versions. to disable some parts. I know maybe this will come.
Oh, it's in the new firmware version, or you're hoping it'll come in a future firmware version?
No, I hope it will, because they still
Yeah.
adding like some things to disable some parts of the GPU, like VCN and all of that is still coming. I mean, it was recently added, like in November. So
I'm just shocked. Which was that? What's VCN?
Video Core Next. I mean,
Oh, okay, like the decoders. The decoders or something else?
yeah.
Cool. Yeah, no, I was hoping there'd be some SMU shut down the memory command, but I didn't see it.
Yeah. I know. My idea was to try like D3 cold state or something like that and just restore PCI like state after
I
that.
tried that. I tried that, and I crashed the computer a few times doing it. It does nothing. You set it to D3, and the power draw doesn't change at all.
Yeah, I see.
Cool. Yeah, I'm excited for the shim binary. I mean, I think kind of the shim binary is maybe it'll almost have the same API as remote.
Mm.
Like, I mean, you can decide what you want it to be, but like the way that I want to do remote for everything is to like have one computer actually just drive the GPUs on the other computer, and then just expose the memory space over some transport layer.
Yeah,
Yeah,
I see.
I wonder if Mac USB should be the same thing. I mean, we could go a little lower level because it is on the same computer. We probably could like and map the region in.
Yeah. I mean, USB is, yeah, kind of the same thing. I think our abstractions are good because we have the memory accesses all abstracted, like for the USB. And I think this will work fine for the remote accesses as well.
Agreed. Yeah, no, it's awesome. We have a great abstraction layer there. So I think that that's the one we should use for remote. Maybe even reuse for the shim. Yeah, I mean, I imagine racks of GPUs with the dumbest computers possible attached to them, and then one computer just powering up all 1,000 GPUs.
Yeah.
Oh, I have one thing to add for MI350. Last week I trained Bird Boat 8 stuff, but for some reason I cannot get AM to work. So I end up just load AMD GPU and use that. The error message was not very helpful. I was not sure if it's supposed to work or am I on like something that was modified midway or something.
I know. What the error message was, do you remember?
I don't quite remember. One of it is like permission error for some file. I think that's the one. I can't remember. I can look it up again and let you know. But I was just not sure if it was supposed to work.
It is. And I
Okay.
think it was, yeah.
Okay.
Yeah, so you
I'll try again and let you know.
Yeah.
Cool. Okay, sounds good. Next for Liz or Jen.
Yeah, Liz now has this feature when you click on the register, it highlights all the producers and consumers of that register. I use some of the infrastructure in our DSL to like parse the register pairs. I think it's been very helpful for my gem stuff because most of the time I'm looking at a gem and I don't know what that register is. I feel like I have this a lot with the gem right now, where it's so low level that it's becoming really hard to change anything about it.
This is a CDNA gem or an RDNA gem?
I mean, like, all of them are the same.
Are they?
Uh, well, yeah, sort of.
So I think that I mean, they're very different, like from like a microarchitectural perspective. I haven't looked much at the CDNA, but the way that you get speed is, I think, quite different. But I mean, even if we don't make it faster, how close are we to just integrating the CDNA fast gem?
Prudent tensor.
Yeah.
I think it will take some refactoring, but we can get there.
I mean, I didn't see that on your sprint goals, but I think that's pretty important. That we have a fast gem being used for our llama trainer.
Also for first gem, you can also test with bird training. Bird training definitely works. And,
Yeah, yeah,
and you have a comparison on master for the flops.
yeah, we should just work on making BERT training faster on MI300, MI350 by using the fast gem. Hopefully, the fast gem in our DSL too.
Oh, absolutely no DSL. I can't read that text book. I can change it.
What the LVM stuff?
No, the like there's a little text file that has the instructions in it.
Yeah, yeah. I mean, the more I think about like the problem with assembly language, it's just the fact that nobody built real tooling for it. Assembly language all has syntax from the 80s. Like, and everybody just for some reason is fine with this because nobody actually codes assembly language. But like it has the programming language semantics of a language from like yeah, like 1982. Um, so when you say tooling for inspecting GPU state at cycle level, and how's that coming?
Well, I think the current SQTT stuff doesn't really show a good picture of what the GPU is doing at every cycle. Like imagine like every wave at every program counter. What's going on? Where is it stalling? Like we don't
I
really
agree.
have anything.
I agree. Have you looked at the output from my SQTT stuff? I think it's a lot more like clear.
I think it only
I,
works on our DNA 3.
I merged it, so you're welcome to add support for RDNA 4. But again, I think the highest priority is just getting fast gems working on BERT.
I see. Yeah. Right.
But yeah, no, I'll merge the when I merge this new refactor to the DSL. I think then it should be kind of good for other people to start working on different parts of it. You're welcome to add RDNA 4 support to SQTT. I don't think it should be that hard. I mean, I'm not sure what it is, but yeah, try it on RDNA 3, and yeah, it's just a lot more like clear to me because basically every instruction has one or two events. The one event instructions are like immediate instructions. They happen. The issue and the completion are in that same packet. And then there's these other ones that have an issue instruction and a completion instruction. And that's just all through the chain. We can also do things like visualize where everything in the warp is. Like visualize where each current thing is, like the program counter of each warp. I think that kind of stuff would be cool to be able to kind of like step through. Actually, if we're stepping through and we have an emulator, we should be able to see all the registers too, like the values.
Yeah, that was thinking like a table of all the VGPRs. And you see them changing.
Yeah, you could like click on one and see the value of it, see how many times it was hit. We'll get there. Yeah. Top priority for the rest of the sprint is getting BERT training fast.
With assembly, yeah. Oh no, I think like the more I think about assemblies, I really want C. But maybe that's just a me problem.
You really want the what?
I really want C syntax.
More than what's in the DSL?
The DSL doesn't solve like indexing into a like the way I think about C is like I index into this stuff and it does the pointer math for me.
Yeah, but assembly doesn't do that. That's just not how assembly works.
Exactly, right? I have to worry about all
Yeah.
this stuff.
All right, so you're struggling with the pointer math. I mean, again, focus on just making existing gems work fast on BERT and then translating them to RDSL. Indexing is never going to get easier. I mean, it's just not a way. There's just not a way to do like the kind of syntax you want. Because a lot of the problem is like, when do you compute those indexes? If you read so I merged the RDNA the RDNA 3 FP32 matmul. And if you look at how much effort is put into indexing and how many like indexes are pre-computed and when you plus equals those indexes, that stuff matters tons for performance.
A
Yeah.
little question.
Next for Llama flash attention.
I saw your multi-device fix. I have a test for it, just haven't pushed it yet.
Okay.
Um,
So I try that. I trend something a trend, but even with JIT equal to 0, it NaN at I think 7th step.
oh,
So I
that's
assume that's progress. I don't know.
because with j equals 0, I've had it train past 50 steps and it's been fine.
Oh, then maybe. Oh, are you training which llama?
8B.
Oh, okay. I guess maybe BERT is too small. I was testing BERT just because I know the BERT output is guaranteed to be correct.
I see. But at least with Llama 8B, I've had it stable without JIT.
Okay. Can you clean that thing up? I think it largely looks correct, but I just don't know too much about the initial design and like
Yeah.
what. Okay.
Yeah, I'll clean it up and merge it along the test.
So the way I did it is basically just supervise cloud code and running now equals to 1 on my computer until it compiles.
Yeah, it's probably fine. Should run on device as well.
Yeah, I mean, I test it on the device after I think it looks good and it also compiles. So that's why that's after that I send it to you. But that's basically all I get that.
Okay.
Okay, so let's get this fix.
Yeah.
Did you make any progress on JIT?
I did not make any progress on JIT. Oh, I did track down. It's very weird. It seems to be just I split QKV backwards into 3 kernels now, one for Q, one for K, and one for V. Only the V kernel outputs incorrect stuff during JIT. Even though V and K have essentially the same computation. It's very strange. I need to look into it more.
Okay. I feel Claw would be also really useful to debug things like that. So just try that.
Yeah,
And
we'll try that too.
what the issue is. I think if this device fix looks good and we can fix JIT, we can back to like good progress.
Yeah.
Okay. Sounds good. Next is my stuff. Oh, so I look into JIT. There was this test JIT guns. I think I made a lot of easy case, a lot of easy case null asserts, and I also include some of the new cases that I found while reading the code. There was a bad use case if you passed a const tensor as an input, because you can never realize a const tensor into a contiguous tensor. That would just fail because JIT doesn't capture that. Now JIT also supports things in list and tuple as input. We don't have a really clear spec on this. For example, should it work if it's a tuple inside a tuple or list inside a list? How about like custom objects and things like that? I initially tried like get parameters, but it got pretty complicated because of the model weight also got captured that you probably don't want the initial init of those parameters. So currently I have a test case for that in test JIT, but it only works if it's a list or tuple. Not even for set. But it's
Yeah.
what it is.
We should probably use like NN state get parameters, and that should just be like the shared way to do it.
Yeah, but there are things in the get parameters that you don't want to capture in JIT.
Why?
The
If you do
just
get parameters on args and KW args, there's things you don't want to capture?
yes.
Like what?
Wait a second. I think it's
Okay.
one of the there's one I look into objects, and that's causing issue with how we used to use models. I can give you an example later.
Jax has these things called pie trees.
Yes.
And yeah, I mean, it's pretty good. I don't know, like if you pass the whole model into the jet, I think it should just capture all those things.
Well,
I
because
don't know.
it also look into like as dict underscore dict, some weird stuff.
Yeah. Yeah. I don't know.
Yes, I initially start with get parameters because that seems to be the unified way to do it. Then there are like edge cases that I'm not too sure about.
Yeah.
So for now, it's we can always expand this. There are also weird cases like I think Nantuple is derived from one of it, but not the other one. Anyway, it's easier to add supports later.
Sounds good.
Then there are the rest of legit. There are a few things I try and I don't really like. There's this like methods class method. It's reuse. I know you suggested check the first if it's self and warm. I don't really know what warm means. We just assert.
What do you mean check the first if it's self?
So now if it's a class method, let JIT is share across the class.
Oh yeah.
That's something like we kind of use it that way. It's weird.
Yeah.
That's more of a corner case. Then there's this case that should JIT in JIT be fail in the first call or the second call. I try to move everything check to the first call, then it ended up being weird because you really want to set j equals to 1 to be a different path and not doing this check, things like that. At the end,
So I had two ideas for JIT improvements.
Mhm.
So one is like if you pass in things that are different sizes to assert, you could like create another JIT text for them. And this would kind of help with that class issue because it's fine if the JIT object is shared. It just creates multiple JIT objects depending on the sizes that you pass in of stuff.
Do we have a legit use case for that?
Yeah, like if you use like in Llama, if you pass in different batch sizes or anything if you pass in different batch sizes.
Okay.
However, that's only going to work if the JIT actually frees the intermediate memory. If it captures all the intermediate memory, you can't like create 10 JITs. So yeah, that's the second idea. Like I wonder if we could free and reallocate the intermediate memory quickly enough to still make the JIT performant. Like the intermediate memory should become one big like slab of memory. That's all just indexed into. And then if we deallocate it and reallocate it on every JIT call, 98% of the time you're going to hit the LRU. So just or right now, like we have a call for this free intermediates. Like I wonder if we could get it fast enough so we could always free intermediates.
But you can imagine, say, when you are training, you know you are not never going to change the size. So even if it's fast enough, you might as well not do that.
If it's free though, I mean, imagine like forget the size thing. I mean, the size thing is just like that becomes easy once you're automatically freeing intermediates. But yeah, automatically freeing intermediates. Like how cheap could that be?
Okay, I don't know. I can look into this.
Yeah, no, just an idea. If it's not useful for the stuff you're working on, then
Okay. I don't think any of those leads to the actual Llama JIT issue, but since Wasferry seems to have a good lead on that, we'll see what we get later. Another thing that I try with Cloud is to use it to solve some. The exact case I was testing was make disk assign. I guess disk slice assign lazy. I think that's a good exercise for it to trace along all the copy, different paths for copy. We have tons of different special case for copy, and see how to use it better in terms of like scheduling change or rangify change. All I can say is it wastes tons of kernels. It seems to understand issue, but it's too hard for it to do anything useful. I think facing schedule issue. I guess we discussed this last week, but the best tools it has is this equals to -1 and try to parse the pickle. So that was not very useful.
yeah, Cloudland, any progress on that? Giving Cloud more context?
At least I can work more. I don't have a like concrete feedback now for what I want. But I think one thing we can think more as people adopt cloud coding more is, are we like wasting too many tokens in our like output debug messages, or the way we represent data? Is it like optimal? We used to design like debug levels and things kind of, I don't know, randomly or semi randomly, and some of these can probably be improved.
So Harold's take on this that I really agree with is that you should never design for the AI. You should only design for humans because what's good for humans is good for the AI.
Yeah, but
But
the old debug level, other than the debug institute 2 and debug institute 4, the source code is not really human readable.
yeah, I mean, and that's a problem, right? Like, but we should fix it for humans. We shouldn't fix it for AIs. Like, yeah, anything we can do to. I mean, yeah, debug equals 3. Like, what really is debug equals 3? Debug equals 1 means something. 3 is just the only one that's kind of
We also have
confusing.
the issue that Viz is designed for human, right? But Viz is like not really helpful for AI coding.
Well, the Viz front end is not, but all of like the Viz is mostly the capturing stuff.
Anyway, I think that's something we can work more, or if people have ideas when you like spend or waste lots of tokens and interact with it. See if we can make the debug information more useful. I think this might be also be similar to like designing the UI UX for assembly. Like people struggle with assemblies, like it's very hard to read and structure with maybe like similar principles. How do we capture the things that is useful to make progress?
Yeah, I mean, I think it's shocking how bad Claude is at writing any assembly. And it's bad at writing assembly for the same reasons humans are bad at writing assembly. Like it's just like gets confused and copy and pastes instructions in places, and then things don't work, and it didn't carefully think everything through. So yeah, I think whatever makes it easier for humans will also make it easier for models. Um, Starting with just like type checking, right? Like now, like my assembly DSL, when you run it, if you put an S where you were supposed to put a V, it throws an error.
Yeah. There was someone said Rust would be the good language for Asian coding because if it compiles, chances for it to work is higher.
Yeah, I don't know. I have the same. My thoughts always on that kind of stuff are like, there's a reason humans code in Python.
Yes.
Um, I could imagine the agent wasting tons and tons of time trying to figure out how to get the borrow checker to be happy when in Python it just could have written something, written tests for it.
Yeah. Oh,
Um,
yeah. But I know what cloud is good. Also, my another side project is go through all the to-dos in Tinygrad and try to do those. Cloud is really good at updating tests or like a simple concept. Just imagine the old linearizer failure test that's very hard to update. It's very easy for Cloud to
oh
do.
yeah, yeah.
So updating those, and it's also pretty good at writing Annex ops because it will pull the ops specs and read the test case and like write the thing for it. You just need to supervise it and tell it to write it better or the way you want. But that's the issue as no matter how many times I tell Cloud to read the diff and make it minimal, it will fail at some point. Then I point out, okay, how about consider write it that way? Then it can write a good code.
Yeah, there's a few times where I'll yell at it repeatedly about the same 5 lines and be like, "No, you could write that in 3." Like, it's obvious what it is, and it just doesn't see it.
Yeah.
Um,
Yeah, but I think it's good to good exercise anyway. Go through. I think we have a lot of some of the old to do code or the skip tasks just because we were like not having enough time to update those properly. I think it's a good time to have help with agents. I mean, I pay for the max plan anyway, so I might as well use those tokens on the side.
yeah, no, the limit is not the AI tokens, the limit is, how carefully you wanna review its work,
Uh, yeah.
and I mean, that's the
I think
problem.
we are getting better, and I mean this round it really fixed a lot of really old test cases. Some of it was even like not even correct. It's just it's always there and no one bothered to read it. So I think it's a good exercise.
Oh yeah, I mean the general quality of the test code in Tinygrad is not that high. So
Yeah.
Um,
Okay.
it's I've been trying the thing. Have all these tests now for like the cycle accurate emulator, and I try to get Claude to write a hardware model that matches these tests, and I've burned hours on it. Can't do it. It's not smart enough.
Okay. Yeah. Let's move on to your assembly stuff.
Yes, I did. I've been going through the files one at a time, and I shove the AI crap out. So now like PDF is very high quality, and today I worked on Inst. I'd say I worked on DSL. DSL is very high quality, and PDF and DSL are everything you need for. PDF is like the auto generator, and then DSL is the like the Python syntax for writing assembly languages. So yeah, PDF and DSL, hopefully by the end of this week, can move into real Tinygrad, and then we can start using them. And we already use them, but we can use them like everywhere. I think that is just kind of nicer than LLVM syntax. The SQTT one is also really really small. I wrote some tests this weekend that do that compare our SQTT to Rock Prof Trace Decoder, and it matches perfectly. So yeah, those three are pretty small. And then I have two files, ASM and disasm, which are an LLVM style assembler and disassembler, and they're just trash heaps. So I don't know about those ones. I don't even know if that's functionality we really want. Or rather just improve the DSL pretty printer to the point that we just use that. And those are nice because they can actually execute in Python. But yeah, it's a complete integrated runtime environment for AMD assembly. I think it'll be in Core Tinygrad by the end of the month, and then start working on an actual assembly backend, or whatever that means. Maybe it's just taking the Tinykit stuff and starting to pin the registers. Yeah, you need a register allocator. So if we have the registers and we have the instruction ordering, it should be really easy to just directly turn that into assembly. And I bet it'll be faster a lot of times than what LLVM generates, because the LLVM is not designed. There's nothing in LLVM that's capable of reasoning about like warps. It's just designed for like interleaving, which like kind of uses the resources, but not really. I also, from the SQTD stuff, finally really understand what warps are. So like the whole GPU has one ALU pipe that all of the warps share. And the warps all submit stuff to that single ALU pipe. And the idea is to keep that pipe full all the time. Like, I guess I knew this, but it's so nice when you can actually see it from the SQTT trace and see stuff going in. So end of the month, be a complete environment, and then write a backend that outputs the assembly. And then we have real zero dependency AMD.
Will it be fast?
It should, yeah. I mean, check out, so AMD as a mapmol is a copy from the Seb blog post stuff, but yeah, it's very fast. Actually, by just cleaning up his stuff, I've managed to get another like 10% of speed on top of his stuff. So I'm getting like, I didn't get his 50 teraflops. I got like 45, but then I managed to get it up to like 50. So it should, yeah. I mean, it should. If it's not fast, we'll finally have a way to understand why it's not fast. Like, if you write something in C and it's not fast, like, okay, why is it not fast? Good luck. The GPU execution model is so complex.
Sounds good. Anything else for you?
Well, and then like looking forward to kind of the end of the year, I think this is going to be the year of LLVM removal. By the end of this year, I want to be able to output NVIDIA stuff too. I want to be able to output SAS, and that has to be reverse engineered, and hopefully the DSP stuff too. And then if you can do all of those, then in 2027, we're finally ready to do our hardware. But we have to get real performance on these kernels. I don't know. Maybe AMD will be excited about these things, posting like we should be able to get the highest performing map on CDNA. There's a ton of stuff that these things all leave on the table because they're all LVM based.
Mhm.
There's no environment for AMD that's not LLVM based. There's some that use inline assembly, but I haven't seen any that just completely do all this stuff in assembly. So yeah, we can get the fastest gem on CDNA4.
Sounds good. Now what do we have for bounties? Oh, I merged the FP8 bird. I mean, I run the script. It seems to be using FP8 for the linears. So I
Is
think
it fast?
it's a bit faster, but now training bird really is all bottleneck flash attention. So yes, the gem is faster, but it's the flash attention still. Or maybe not all flash attention, but it's more difficult to assess because bird is so small.
Yeah, I mean, I don't buy that this theory that like if that bird is so small and if that's why the flash attention's unstable. It doesn't make sense to me. I think there's probably the flash attention being unstable because bird is small. That doesn't make sense to me. I bet there's some instability with like how the max thing is being done. I bet the max thing's being done wrong.
Maybe.
Like there's a lot of ways to subtly do flash attention wrong that's going to get you these kind of nans that doesn't have anything to do with the JIT or doesn't have anything to do with. There's no like. What do you mean? It's like it's too small. I just don't buy that. Hold on. We should write some.
Oh, you are talking about the NAND issue earlier?
Yeah. Yeah, if bird is all
I
bottom.
don't know. Yeah, maybe flash attention has a bug or something.
I probably does.
Yeah.
Probably flash attention backward has a bug. Flash attention forward is easier to write. Flash attention backwards. Ooh.
Yeah, we'll see.
So hopefully we get that this week
Yeah.
or next. But yeah, I just don't buy this whole thing that BERT is too small to train with our flash attention. Our flash attention has to work on BERT.
Yeah, that I agree. Okay. I don't know, B1T, do you have anything to add for float 8?
Hello.
Hi.
Oh, I add a seed to the data server, so we can compare it with the half rounds.
Have you confirmed that with the same seed, you will get the same, like exactly the same loss?
Yes, with the same seed, the loss and the LM accuracy stay the same.
Okay.
I post a picture. When there are few rounds with a different seed.
Yeah. So the flop is higher. Yeah, I mean, I'm aware of this. Then I also train that branch on myself so that I merge this. I also know that you didn't split the setup, so there's no cache. And if I run it twice with the cache, it will be faster. But what really matters is the step time. So that's fine.
Yes, and the clamp seems the clamp you changed a few weeks ago make the kernel slower. If I change the clamp to minimal and max, it will be faster.
Oh, I don't remember anything. Maybe I did.
A few weeks ago, I asked that we should match the clamp API backwards behavior with the touch.
Oh yeah, are we matching
Yeah,
torch now or no? I think we do.
we match touch now, but
Yeah, but it's slower.
but it's slower. Yes.
Well, I don't know. If you can make it faster, then that's great. Otherwise, I think matching torch behavior on these numericals is preferred, even though it's slower for now. It's just one ALU.
So generally, FP8 is more is faster than the FP16.
Cool. Okay, sounds good. Other bounties do we have? Do people still do bounties?
Gotten hard with all the AI stuff. Like the problem is we just get so many submissions now. Like I had to delete that other bounty because we get so many submissions from people who just like casually threw Claude at it and then just was like, oh, okay, I don't know. Submit it when all the value is actually in the validation, not in the work now.
I will review the Whisper one. That seems to be fine. I just comment on it. I think some of the cleanup can be separate into smaller PRs. That also helps Tinycorp proper. I think this is still true for anyone who wants to contribute. If you can split your PR into individually useful pieces, just do that. Because you know that the bottleneck is the maintainers and reviewers reading the code. If you make it simpler, smaller, easier to understand, the chances for it to be picked up as someone is higher. If you just open a PR that has like 500 lines and has questionable benefits, no one, it's not even like people won't close it, people will just skip it. So don't do that. I think that's it for this meeting. We will discuss about the meeting time next week. I think realistically, it's either the same time or maybe 1 hour earlier. I will discuss it later.
Sounds good. Yeah, I'm I'm so tired.
Okay, that's it for this one. Thank you, everyone. See you next week.
Bye.
Bye bye.